This is Roland Leong, Managing Editor of Shotgun Report. We are going to chronograph, pattern, and analyze a shot shell. It will be the Federal 12-gauge 1-ounce, 1180 feet per second number 8s, shot through a Beretta DT11 using a Muller U3 choke. We'll be using an Oler 35P chronograph. The muzzle will be 8 feet from the first screen. We'll be using Shotgun Analyzer version 4.1.5 by Target Telemetrics, running on Windows 11. If you find this information useful, please subscribe and please like. We fired 5 shots through the chronograph, 5 shells through the chronograph. You can see the data on the tape. The fastest velocity was 1194 feet per second. The slowest velocity was 1159 feet per second. The extreme spread was 35 feet per second. The mean of the 5 shots was 1179 feet per second, and the standard deviation was 14 feet per second. The first pattern .330 pellets hit the sheet. The center of the pattern was slightly to the left and above the green aim point. 50 of the 50 pellets hit the 10-inch, were within the 10-inch green circle, giving a 0.64 pellets per inch density in that 10-inch circle. In the 20-inch circle, 142 pellets were counted with a pellet density of 0.45 pellets per square inch in that 20-inch circle. In the 30-inch green circle, 243 pellets were counted in the 30-inch circle, and the pellet density in that 30-inch green circle was 0.34 pellets per square inch. In the 25-inch red circle, 189 pellets were counted with a pellet density of 0.39 pellets per square inch. Assuming a standard clay target at normal tilt, in the red 25-inch circle, the software calculated that there would be a 97.3% chance of a kill of the standard clay target at a normal tilt being killed. The software calculated that with a standard clay target flying through the 25-inch circle, that it would be a 97.3% chance of it getting killed. The shot ratio, 64% of the pellets were above the horizontal line and 36% of the pellets were below. 73.64% of the total pellets that hit the sheet were within the 30-inch circle. This is the second pattern. And as you can see, this pattern was considerably to the left. "332 pellets hit the sheet. 68 pellets were in the green 10-inch circle. In the 10-inch circle, there was a pellet density of 0.87 pellets per square inch. In the 20-inch green circle, 171 pellets were counted. In that 20-inch green circle, there was a pellet density of 0.54 pellets per square inch. In the 30-inch green circle, 273 pellets were counted. In the 30-inch circle, there was a pellet density of 0.39 pellets per square inch. In the 25-inch circle, red circle, 228 pellets were counted with a pellet density of 0.46 pellets per square inch. In the red 25-inch circle, it was calculated that a clay standard target at normal tilt would have a 97.96% chance of getting killed or broken. The shot ratio was 58-42, with 58% of the pellets being above the horizontal line and 42% below. The 30-inch pattern was 82%, which essentially gives this particular choke almost greater than a turkey type full choke. The third pattern was more centered. 315 pellets were counted on the paper. 53 of the pellets were in the 10-inch green circle. Pellet density 0.67. 150 were in the 20-inch green circle. Pellet density of 0.48. 243 pellets were in the 30-inch green circle, pellet density of 0.34. 208 pellets were in the red 25-inch circle, pellet density of 0.42. A 96.18% kill percentage in the red circle on a clay standard normal tilt target. Shot ratio of 58% above the line and 42% below the line. 77.14% of the pattern was in a 30-inch circle, giving greater than turkey full type choke for this particular pattern. The fourth pattern was slightly to the left. 334 pellets struck the paper. 47 pellets were in the 10-inch circle, pattern density 0.60. 156 pellets were in the 20-inch circle, pattern density 0.50. 264 pellets were in the 30-inch circle, pattern density 0.37. In the 25-inch circle, 219 pellets with a pattern density of 0.45. Kill percentage 98.33 on a clay standard normal tilt target. Shot ratio 50-50 on this one. Again, a very high 79% of the pellets percentage in the 30-inch circle. Very, very tight choke equivalency. And finally, the final pattern. "331 pellets hit the paper, 10 pellets, 10-inch in the 10-inch circle, 443 pellets with a pattern density of 0.55. The 20-inch circle, 158 pellets, pattern density of 0.50. In the 30-inch circle, 273 pellets were counted with a pattern density of 0.39. In the 25-inch circle, 212 pellets, pattern density of 0.43, 99% kill possibility of a clay standard normal tilt target within a the red 25-inch circle. Shot ratio is higher on this one. 73% of the pellets were above the line, 27 below. Again, a very tight choke on this. 82% of the pellets were found within the 30-inch circle. Now, what does all this mean? Were the 1-ounce AVCI shells better than these federal 1-ounce shells? Well, let's take a look and see. We took the pattern densities of these AVCI shells and the federal shells and put them down at 25 inches and at 30 inches. And the mean average for these two numbers, for the AVCIs and the federals, are here, 0.476 for the AVCIs and 0.43 for the federals. So one could look at the average and say, yeah, the AVCIs are better. The pattern density is higher for the AVCIs than they are for federals, so the AVCIs are better. Looking at the 30-inch pellet density, the AVCIs are 0.41 and the federals were 0.366. So again, the AVCIs had a higher density, so the AVCIs are better. Well, you could say that, but you would not be necessarily correct. The other way of looking at it would be to run these numbers through a statistical program analysis called a t-test, which is essentially what I did here. And I used Excel to crank numbers, and I won't go into the statistics for it, but I would basically explain that the important numbers are this t-stat and a critical two-tail, and that essentially the hypothesis is we're saying that there is no difference. The hypothesized mean, we're saying that there is no difference between this mean and this mean. And we're trying to prove that or disprove that conjecture. And the statistical number is generated is this number. And this is the calculated number that we compare it to. And as you can see, this number is less than this number. And that essentially means that we cannot reject this hypothesis. So that what we're basically saying is that there is no difference, statistical difference, between these two numbers. So we're saying that under the conditions that we shot, which were static 40 yards on this particular day through this particular gun. There was no statistical difference between the pattern density at 25 inches between the AVCIs and the Federals. Then we did the same calculation at the pattern density numbers at pattern density at 30 inches. We did the same type of analysis, and we could not reject the null hypothesis, which was that there is no difference. So we could not reject. You see, this was the t-stat. The critical t-stat did not exceed this number. We could not reject the null hypothesis. So again, these two numbers were not statistically different. So statistically, there is no difference on this particular day between this particular gun with these particular shells shooting at a static target. There were no statistical difference between the AVCIs and the Federals. Whether you choose to believe this or not, entirely up to you. But this is our analysis on the difference or no difference between the AVCIs and the Federal 1 ounce eighths. Thank you very much.